สวัสดีค่ะ My name is Kitika and my student ID is 54672006. Today I will be presenting the measurement of forecast accuracy, which is the process of measuring forecast accuracy. For example, there are various methods including the average and trend projection and so on. Today I will be presenting how to measure the forecast accuracy. There are three of them. First are the mean square error, which is the initial name is MSE. Usually the table will be providing the three columns, including the period, the actual, and the forecast. An example that I will provide here is I have a total of 6 periods. And the actual number for the period 1 is 90, period 2 is 95, period 3 is 115, 4 100, 5 is 125, and the 6th period is 140. And the forecast number is for period 1 is 100, 100, 100, and the rest is 110. First of all, I need to find an error first. As I go back to the first, the name is a mean square error. First, you have to identify the error, and then the square, and then the mean or the cumulative. First, I will identify the error first. The error is, the way you calculate the error is you get the actual number for the period 1 minus with the forecast number for the period 1 as well. So it's 90 minus 100 is minus 10. So you do the same thing with each period. This one minus 5. This one is 15 minus 10, 15, and 30. The next column is you need to identify RSFE. You must identify RSFE first before you actually find the tracking signal at the end. So the RSFE, the way you can define is you get the sum of error. So the first period, the RSFE is minus 10. So you get minus 10 plus minus 5, which is minus 15. And you do the same thing as the rest, so it's 0, 10, 5, and the 6th period is 35. The next column you will identify is a square column. The square column is you get from the errors here times 2. So you get minus 10 times 2 equals 100. You do the rest of the column as well. It shows 25, 225, 100, 225, and the 6th period is 900. The next column is the mean column, or I call it here is a cumulative column. The way you identify cumulative column is you get the sum of square here. So the same thing, you put 100 first on the first period. 100 plus 25 from the square period 2 is 125. The third period is 350, 450, 675, and 1575. Then you identify the MSE period here, the column here. MSE here, the way you find is you get the, look at the first period first. From MSE, from the mean period is the first one is 100. You get 100 divided by period is period 1. So it's equal to 100. The same thing, you get 125 and you divide it by the second period will be 63, and you do the rest of the column the same thing. Okay, the last one is a tracking signal. I will write a note here because there is no space left. The tracking signal here, the way you can find is you get the RSFE column, you divide it by MSE, so you get minus 10 divided by 100 will be minus 0.10. So you do the same thing to the rest of the column. So in conclusion here, we get the MSE equals to here 263, and the tracking signal equals to the last one here is 0.13. As you can see for the table here, the way you need to identify which this by this method the mean square error, if it is accuracy or not, is to look at the tracking signal here. The last column, the last period here, the sixth period, it shows that the tracking signal is 0.13. So you have to see from the rest of the fifth period above that the error should not be swing no more than 0.13, which is, it shows here that on the second period, the tracking signal is minus 0.24, which is more than 0.13. So in conclusion here, I can say that this one is not acceptable limit. Okay, my first equation is done. So I'm going to go for the second equation here. It's called